Hi everyone, welcome to OnlineI. In this short presentation, I want to talk about the phrase net zero energy building. What exactly do we mean by this? And I'm going to illustrate it by looking at photographs of a net zero farmhouse project that was recently built in Vermont. So what is net zero energy? In a nutshell, it's the idea that your building generates all the power that it uses. So it seems straightforward. The reason why it is net zero is where it becomes slightly complicated. So if you look at this slide, we're looking at this house which is facing south. It has active solar photovoltaics on the roof that are generating power. You can see at this moment, actually, because it's the bright middle of the day, the lights inside the dwelling are off. And it's also likely that the appliances are not necessarily being called upon at the moment. The refrigerator is running, but the washer and your hair dryer and your computer may not be running at this moment in time. So what this means is actually you're producing more power than you actually need at this moment, at noon, let's say, on a bright sunny day. However, if you look at this slide, you can see that the photovoltaics at this moment in time are not producing any power. And in fact, the lights in the dwelling are on as the sun is going down. People are home. They're using electrical appliances. They're using heat or cooling. And so at this moment in time, this house is actually drawing power from the grid. It is not supplying its own energy needs at the moment. And typically what happens is you can think of this as a daily cycle where the photovoltaics are generating more power than is needed during the day. And they're actually selling power to the grid or taking that as a credit so that at night when it's drawing power, it ends up roughly back at zero. So there is a daily cycle that is involved in a net zero energy house. There's also a seasonal cycle because during the winter months, there is less sunshine and less power available, therefore. And in the summer months, there is more. So the net zero idea also takes into account the seasonal variations in the amount of power that can be generated. So over a full year, you're essentially accounting for your power generation and your power use, and you end up roughly breaking even when you take all of these daily and seasonal cycles into account. That's what a net zero energy building does. One of the things that is considered to be a little bit of a problem with net zero, and I think if you look at this picture for a minute and think about it, is that you can see that this is a single family home. It's in a rural setting. So the people who are living in this house are actually using a lot of power. Their carbon footprint is high because of their distance, for example, from work or from shopping or recreational activities. So the carbon footprint of this kind of dwelling is not necessarily lower just because the dwelling itself is net zero. And in general, the idea of net zero seems to have really taken hold in single family homes. If you think about it, imagine this dwelling just going up 8 stories and 8 families living in this, you would still have the same amount of roof area per the 8 floors of the building, which means that you wouldn't be able to provide all the energy that you needed on the building for the 8 dwellings. However, because each of those dwellings would have an energy budget, right? So you'd be roughly producing, let's say, 1/8 of the necessary power. However, that pattern of building more compactly and having people live closer together would probably be overall more environmentally sustainable. So one of the knocks on net zero energy is that this doesn't really help us achieve our big picture goals on sustainability. It sounds so seductive that the idea of your house producing all the energy needs for its occupants, but this may actually not be the best way to think about sustainable building. I want to go through a couple of other points about net zero. A net zero energy building would mean the building itself has enough photovoltaics to power itself over a year. Okay, so this is an example of a net zero energy building. But in fact, you can use additional photovoltaics located elsewhere on the site to generate more power. So you might notice, for example, that the garage roof is not oriented toward the south. But were that volume to be reoriented, you could actually generate more power by installing photovoltaics on the roof of an auxiliary structure, or you could mount solar panels somewhere else on this site to produce additional power. That would be a net zero energy site. There's also the idea of a net zero energy community. So across an entire neighborhood, you are working to generate the power that you need. And the Carolyn Hashem Vermette reading deals with how that works in practice. It turns out to be very complex, how you would create enough power across an area of several acres to power all the structures within. So if you're interested in that topic, you can look at that additional reading. I want to talk briefly now about our core reading for today. I'm going to do half the work for you and kind of walk you through what Wolfgang Feist says about the passive house standard. And then I want you guys to look at the other figure who is advocating the active standard, figure out how he is defending the idea of an active house. Why is he interested in net zero energy as a standard? You'll notice that this is really an interview, this article, so it allows each figure to present their case, but it doesn't really synthesize or take a position on which is best. And that's what I'm going to be asking you to do in the discussion prompt. Okay, so here is what Feist says about passive house. He says that passive house deals more with how the structure is built rather than the technological systems that power it. As you know, there are, in fact, fairly complex technological systems in heat exchange recovery, ventilation. So I'm not sure that that's really a strong argument, but that's what he says here. He also says that passive house has been around longer, so there's been more time to sort of iron out difficulties and learn from mistakes empirically as these structures have been built. He also says that you might prefer a passive house even for reasons having nothing to do with sustainability, simply because the high standard of ventilation makes these very healthy houses, and the even comfort of these houses, the fact that there are no cold corners or drafty windows, makes them very comfortable for their occupants. So that might be another reason why you would prefer a passive house to to one that has active solar. He also mentions the new German environmental building standard, which is called ENEV. And obviously we're in a different national context here, but he points out that this standard addresses some of the energy budget of a house, but not all of it. So it includes energy that is being used for heating, energy that is being used to provide hot water, and energy that is being used to run mechanical ventilation systems. But it does not include the energy budget for running electric to your lighting or to any other appliances. So what he's pointing out is that when you say you've met 100% of this new German standard, you haven't really provided 100% of the building needs. So he points out that's sort of an important loophole in the German context when active houses make this claim that they're meeting 100% of the standard. They are, but that's not 100% of the actual need. He also makes a point that I think is really important one for you to think about as you're trying to wrap your mind around these different building standards. And that is, if we have the ability to purchase our electricity, and therefore a large part of our home's power budget, if we can purchase our electricity from 100% renewables, so either, for example, wind farms or solar farms or a combination of both, then is there really any point in mounting photovoltaics to the roof of our own dwellings? Essentially, what we're doing is purchasing energy through the grid that is generated by renewables. And therefore, the need for installing our own active solar systems on our own dwelling diminishes. I think that's an important thing to think through as you're sort of trying to feel your way through these different standards and what they entail. The last point that he makes, the interviewer says, passive house doesn't take a point of view on embodied carbon. So this is the environmental impact in the first part of the life cycle, the construction. So the materials that you're using, for example, how far they have to be transported, what the environmental costs are of the materials you're using. And Feist says something very interesting about this, which has jived very much with my own research on this, which is that when you look at discussions about embodied carbon, what you actually find is different manufacturers who are promoting different types of products. So for example, they're promoting insulated concrete forms, or structural insulated panels. They're promoting certain kinds of green concrete or building block. What they're doing is they're telling you why their product is superior, and there isn't really independent research verifying their claims and doing life cycle analysis on their product. So you don't really have a way of there isn't an independent yardstick to measure these new green building products against each other. So what Feist says is that he doesn't really want to get involved in that debate. He wants to stay away from it and just focus on how the building performs in the operations phase of its life. So I think that's something that you should also be thinking about as you read this dialogue between these two advocates for different building standards, and think about the examples. So I wanted to just provide the examples here together. These are also on our Canvas page. One of them is a net zero retrofit of a building called the American Geophysical Union, which is a scientific research organization. It's their national headquarters located in Washington, D.C. Their building needed some serious work, and they thought that they should do a net zero energy retrofit. So you can read about that project at this link, and there's also a link on this page to some photographs so you can see what the building looks like. So this is an example of a retrofit. And then there is also a really good detailed example in this piece called Passively Net Positive that talks about new construction and a situation in which net zero made a lot of sense. So these are two pretty rich examples for you to think through what net zero can provide and what it can't as you prepare to write your discussion post. Okay, good luck with it. Thank you.